So, okay, be sweet.
Amnesia, please don't drink my water. Your mouth is disgusting.
Okay, shh. Okay, so today you're going to learn the fundamental theorem of calculus. There are two of them. Today you're going to learn the first one. Today should be an easy day. We have 7 examples. Okay, it shouldn't take us that long, but we're not off to a good start.
Wait, how many minutes?
I mean, less than it's going to end up taking y'all if we don't get going.
Let's go.
So, okay, the integral of little f from a to b is capital F of b minus capital F of a. Now, do any of you guys remember what capital F stands for?
Derivative of x.
Not derivative. Very good. So I'm going to put here where capital F is the antiderivative of little f. Okay? Now, the other version of this is sometimes instead of using regular F and capital F, they'll do this guy here, where it'll be the integral from a to b of f prime of x. Okay, but think about, if I want the antiderivative of f prime of x, what would that be called? Regular f of b, and then regular f of a. But then you're still subtracting them. But they're the exact same thing. It doesn't really matter. Typically, okay, you will see this one more often, okay, with the capital F notation. But you should know that they are the same, okay? So, capital F is the antiderivative of regular f. You plug in b, which is the top endpoint. You plug in a, which is the bottom endpoint. Then you subtract. Okay? So, we have 7 examples. We can do it. Okay, example number 1. You are going to take the integral from 2 to 6 of x minus 7 dx. Okay, fundamental theorem of calculus. The first thing that you do is you take the antiderivative of the function. So if my function's x minus 7, not a derivative, an antiderivative. Okay, so I increase it to be x squared. Then I divide by 2, I get a 1/2. Antiderivative of minus 7 is minus 7x plus c. Okay, and then the notation that you typically will do is you will find capital F of 6 and capital F of 2 just here on the side. Okay, and then what am I going to do with capital F of 6 and capital F of 2? I'm going to subtract them at the end. So I'm going to plug them in, find the numbers, then minus. Okay, so 6 first. What is half of 6 squared? So 18. Okay, minus. Okay, then I want 7 times 6. That's 42. Now remember, there's still a plus c on the end here. We're going to just kind of ignore that right now. What's 18 minus 42? Okay? Wow. All right, then on the other one we're plugging in a 2. Maybe we'll have a little more luck with plugging in a 2. Okay?
Release the students that are on Miss Reeling's email from yesterday for the Detroit High film. Let's go.
Okay? Then half of 2 squared is half of 4. What's half of 4? Minus 7 times 2 is?
14.
Okay, 2 minus 14 is?
Negative 12.
Negative 12 plus C, Ebenezer. I'm going to check the email.
Check it.
Okay, good. And then from there, remember, you subtract these guys. So I'll do negative 24 plus C minus negative 12 plus C.
Oh, never mind. Negative 12.
Okay, minus a negative will switch to be a plus. So you'll have negative 24 plus C plus 12. And then what's going to happen with the C's? Yeah, one's a plus, one's a minus. So those are going to eliminate. And then negative 24 plus 12 is? negative 12. The c's will always cancel, so after the second example, I'm not going to continue to write them.
So that's the answer?
Yes. Now, what is that the answer of? What does this integral represent? What is it measuring?
The area
Area
the slope span
between the graph and the x-axis. So we're going to sketch a little graph to show why it came out negative.
Yeah, this is gonna
No.
be rough. This is gonna last you all the whole class.
Okay. So what is x minus 7? What does this equation look like?
a line. It starts
Okay, it's a line.
at
It starts at negative 7.
with a slope of 1.
Okay, good. There it is. Okay, y equals x minus 7. And then if I was only shading from 2 to 6, that means I would have shaded this shape. Now does it make sense why our integral came out negative? Okay? Okay, so remember, that tells me, okay, guys, come on. Okay? That tells me that not only did I have 12 units of area, but they were all below the x-axis. Yeah? Okay, one example down. Only 6 more to go. Okay. Next one, we're doing the integral from 0 to 2 of the function 6x squared plus 1 dx. Okay, what do you do first?
Get the antiderivative.
Antiderivative, so I'm going to add 1 to x squared, what do I get? X cubed, then I divide the cubed on the 6, now it's a 2. Antiderivative of 1 is 1x plus c. Then from there, what do I plug in? 2 on top, 0 on bottom. That's where what those numbers are for. So f of 2, f of 0. It does matter that you keep them in order, because you have to do top minus bottom. Okay? So on top, I'm plugging in a 2. What is 2 times 2 cubed? 2 times 8, which is 16 plus. 1 times 2 is a plus 2. Then a plus c. 16 plus 2 is 18 plus c. Good. Okay, next we're plugging in 0. So 2 times 0 is 0. 1 times 0 is 0 plus c, which means that I have really just a c. And then what am I doing with those two? Yeah, by subtraction. So you do 18 plus c minus c. These guys cross out. Total area is 18. So if c had a number besides 0 with it, I would group it in parentheses. But since it was a 0, I'm really only subtracting the c. Okay? Okay, we've done 2. Only 5 more left. Okay? Okay. No.
Miss, make a graph.
Okay.
Stop that graph.
Okay, it's, well, but remember, what are we finding the area under? 6x squared.
It's positive.
Right? So my graph, if I shaded here, okay, that would tell me the exact amount of area from 0 to 2. Okay? And how much area is there? 18 units. Okay?
All
right. Yes?
It gets bigger when it's a 6.
It gets steeper when it's a 6. It does not get wider. It gets narrower.
If it's like a half, then
If it's a half, it gets wider. Yes. So you might think 18 seems like a lot of area. It's because 6x squared is very steep. So it goes up really fast. That's why you have so much area. So really, if I was going to draw my picture better, maybe it should be more like that, so it's really skinny. And that would show why you're actually trapping so much area is because of how steep it is. Okay, I would never shame a body of a graph. Okay, turn to the page. Next one. Number 3. Okay, we are going to take the integral of sine x from 0 to 2 pi. 0 0 to 2 pi, what is the antiderivative of sine x? Okay, negative cosine x plus c. Now, actually, I wasn't going to put it, but this is the last one. Then we're not going to put the c. It always cancels out, so who cares, right? Okay, so we're plugging in a 2 pi on top. What is the negative cosine of 2 pi? Okay, cosine of 2 pi is the same as cosine of 0, which is 1. So it's negative 1 plus c. On the bottom, we're plugging in 0. What is f of 0? Negative cosine 0 plus c. Cosine of 0 is still... Okay, so then it's going to be negative 1 plus c. Then what do I do with these two? Subtract. So I'd have negative 1 plus c minus negative 1 plus c.
0.
Okay, the c's cancel out. Negative 1 minus a negative is a plus 1. How did I get 0?
Is this true? Negative 1 plus. Oh, wait,
It does not exist.
Think about the graph.
the graph is straight line up and down. Oh, wait, 0 up and down, up and down.
Okay, what does sine do? It accumulates area above and then below. And then what happens with the areas if they're congruent?
Nothing. Yanni.
Berkner buck for Nikki. The Berkner store.
Yes, sir. I said 0 already.
Okay, but we already knew the answer was 0. The point was the graph.
Nah,
Okay?
That's a sort of whatever. I don't care.
You want my burger, bud?
What?
I don't want a burger.
Okay, number 4.
I always have.
Okay, the integral of 5 secant squared. Okay, focus.
The what?
Okay, from pi 6 to pi fourths. Pi 6 to pi fourth. Okay, what is the antiderivative of secant squared?
Tangent theta.
Good, 5 tan theta. Now,
I had my star going too.
yes. Okay, there's a plus c.
Yes, keep it up.
Focus. But I don't care about the c because what's going to happen? Okay, no one cares. So we want f of pi fourths. Then we want f of pi 6. Focus. Okay, how do I find the tan of pi fourths? It is 1, but how do you get that? You do sine of pi fourths divide by cosine of pi fourths. No.
Hell no.
Okay, or unit circle is fine, but you'd have regular root 2 over 2 divided by root 2 over 2, and what do you get? 1. Okay, guys. Oh.
Miss,
Okay.
it's confusing.
5 times 1 is 5. Okay? Now, when you're doing pi 6, you're going to need to find 5 tan of pi 6. So I need the sine of pi 6 divided by the cosine of pi 6. Okay? So sine of pi 6 is a half. Okay, you do your trig. So here's pi 6, 1/2. Cosine's root 3 over 2. How do you divide fractions, though? Yeah, so you'd have 1/2 multiplied by, and then you do 2 over root 3. 2's cancel out. I have 1 over root 3, but then multiplied by what? So it's really 5 over root 3. Now, the good news for you is that AP test, they don't care the square roots on the bottom. They would just leave it. So your answer would be 5 minus 5 over root 3. Okay? 5 minus 5 over root 3.
I'm so lost.
Wait. I'm really used to just like simplifying all the way because of Mr. Daniel.
Okay?
So like I just
You totally can. So if you wanted to do that, okay, it's a worthwhile skill, I guess, to review. You'd put a root 3 here and here, and then you'd have 5 minus 5 root 3 over 3. Now, if you're going to do that, you might as well get a common denominator. Okay, times by 3, top and on bottom.
Yeah, no, that's just
So it's 15 minus 5 root 3 over 3. Now, again, hear me say, would they make you do that on the AP test? Probably not. In college, maybe, depending on how evil your professor is. Okay, but this is good enough for AP. 5 minus 5 over root 3, you're done. But if you want to rationalize, do it. You want to get a common denominator? Do it. Just don't do it wrong or you get the wrong answer. Okay? All right, only 3 more left. Okay? So, this is your answer. I would just leave it like that. Okay. May I turn the page?
Yes, ma'am.
Okay. 3 more left. Okay, the next one, number 5, is going to be the integral from 2 to 10 of 4 over x plus 2 dx. 4 over x plus 2 dx. What is the antiderivative of 4 over x?
4ln.
Good. Okay, technically you do need the bars. What's the antiderivative of 2? Anybody care about the c? Nope. Okay, then f of 10 and f of 2. Okay, top, I have 4 ln. Now, is the absolute value of 10 just still 10? Yes, so I don't have to put the bars. If I'm plugging in a positive number, I've already basically taken the absolute value by leaving it the same. And then what about 2 times 10 here? That's a 20. Okay, bottom, we're plugging in a 2. I have 4 ln 2 plus 2 times 2 is 4. Then I need to subtract those. So I would have 4 ln 10 plus 20 minus 4 ln 2 plus 4. Now, they would not leave the answer like that. There are things that can combine. So the first thing that I'm going to do is these guys have special rules that we'll talk about in a second, but I'm going to pull those to the front. So I have 4 ln 10 minus 4 ln 2. Okay, but then the two numbers, we can put those together. So if I have a 20 and then a minus 4, 20 minus 4 is 16. We're all good with that? Okay, here's what you can do with the ln's. The first thing you need to do is take the 4 out. They both have one, so I can remove it to the front. Which means really I have the ln of 10 minus the ln of 2. Now, there is a special rule for logs when you are subtracting. What can you do with the 10 and the 2? Yes?
Divide.
Yes. Okay, so there is a special rule. ln of A minus ln of B is the same as ln of A over B. Okay, now you should have learned that in pre-cal. The other rule that's very similar to that is log A minus log B is log A over B. Any rule that applies to a log applies to an ln. So they would not leave ln of 10 minus ln of 2. They would divide the 10 and the 2 and make it a what? 4 ln 5 plus 16. Now, there's one other thing they could do. Where can that 4 move? Do you remember? That it can move up here? Okay, but they probably won't do that, but they could. Okay?
Wait, where can we?
So this is the same as ln of 5 to the 4th. Do you remember the rule that you can take this number from the front and you can move it up top? Okay, but I have not seen them do that on the AP test, but they could if they wanted to trick you. That's also a rule. But probably that is how they would leave it.
Subtract them.
Okay? All right, 2 more left. Number 6. Okay, we are going to take the integral of 3 square root x plus 4 square root x cubed dx. Okay, and we are going to do it from 1 to 4. Okay, what do you guess we're going to do first? Okay, I'll rewrite. So I'm going to rewrite my integral as 3x to the what if it was a square root? 1/2. Okay, remember it'd only be negative if it had been on the bottom, right? Okay? Then my x square root to the 3, that's really x to the what? 3/2 dx. Okay, let's take the antiderivative. When I add 1, I'm going to add it as 2/2. So 1/2 plus 3/2 is x to the, I said that wrong, but you know what it is. What is it? 1/2 plus 2/2 is 3/2. And then if I divide by 3/2, what do I put in the front? 2/3. But what was already there? A 3. What's going to happen with the 3's? 3 here, the 3 on bottom here, those guys can go away, just be a 2. Plus, next term. I have a 4 in the front. Add 1 to 3/2. What is 3/2 plus 2/2? X to the 5/2. Then what do I put in the front? A 2/5, which will give me eventually 8/5. Now, plus C, again, nobody cares, leave it out. Okay, I am going to rewrite this one more time before I start plugging in. So my x to the 3/2, I'll write as an x cubed and square rooted with a 2 in the front. And then for this guy, I'm going to do what Zhang said, that's the same as 8/5, because you have the 4 times 2 gives you 8, and then the 5 chills on the bottom. Okay, then for your x, it's a square root and then an x to the 5. On the top, I will plug in 4. On the bottom, I will plug in a 1. Now, when you are plugging these numbers in, remember that you should always do the radical first and the power second. So when I'm doing this first one here, I would do 2 square root 4 cubed plus 8/5 square root 4 to the 5th. And then the order that you would do it is you would work out the square root first. What's the square root of 4? 2. What's 2 cubed? Then multiply it by 2. So that's a 16 plus.
I have a question.
Yes?
It's not off topic, but I always wonder, like, why can't the square root of 4 raise to 3? Why can't you just, like, raise 4 to the second power?
Talk later. Y'all finally just got quiet. Okay. Next one. Square root of 4, what is it? 2. What's 2 to the 5th? So I have 8/5 times 32. Now, if you don't know how to multiply, let's review. 32 times 8. 8 times 2 is? Carry the 1. 8 times 3 is? Plus 1? 25. So that is the same as 16 plus 256/5. Okay, that level of math you should be able to do. Okay, on the bottom though, easy, I'm plugging in a 1. What is 1 to any power when I multiply it by 2? 2 plus. What is 1 to any power times 8/5? 8/5. And then what am I doing with these two things? Subtracting, right? Now, when you subtract, I would subtract the like terms together. So I'm going to write it out first. 16 plus 256/5 minus 2 plus 8/5. And then what is the 16 take away the 2, the both whole numbers? 14. And then what is 256/5 take away 8/5? 248/5. Okay? And then if they were to get a common denominator, you got to think like as easy as possible. Okay, if it were free response, you stop here. Okay, but if it's multiple choice, instead of me getting a common denominator twice, I would put the whole numbers together, put the fractions together, and now I just have to get a whole number common fraction once.
Unless
So-
you do last one.
Huh?
Let's not do last one.
Well, we got to finish this. So 5 times 5. What's 5 times 14? 70. Okay, and then what's 70 plus 248?
3.
Over 5. Okay, If you don't remember, don't forget. You can always do that. It doesn't take that long. Okay, instead of guessing. Or you could do 5 times 10, and then 5 times 4, and then add them together. Okay? Last one! You ready? One last little example. Good? I don't know, you guys today. Well, if I'm grumpy or if you guys are grumpy. Okay, last one. We are going from 1 to 9 of, what is it? 3x plus 5 over square root x. Okay, first thing that you should do, anytime you have one thing on the bottom, you should get a common denominator. So I'm going to rewrite this RW as 3x over root x plus 5 over root x. That's the first thing that I would do, is I would split up. If they're both divided by root x, then they can be divided by root x separately. And then, what do you do if you have x to the 1 on top and x to the 1/2 on the bottom? What do you do with their exponents? Subtract. So, what is a full x to the 1? Take away a half x. 3x to the half. Now, look at your second term. He doesn't have any x's on the top to subtract with, then I can just bring that up and turn it negative. So the second term is 5x to the minus a half. Does that make sense? So here, when you have x's on top and on bottom, you minus to know how many are left over. But since he only has an x on the bottom, I just pull it up, turn it negative, move on. Okay, add 1 to a half. What do you get when you add 2 out of 2 to 1 over 2? Okay, so that's x to the 3 over 2. Then I have to put a 2/3 here, but there was already a 3. So, just a 2. Plus, next one. What's negative a half plus 2 out of 2? Positive a half. Then I have to divide by half. What's that the same as? Multiply by 2, but there was already a 5. So now that's a what? 10. So now I have 2 x to the 3 square rooted plus 5 times 2 is 10 square root x. And then from there, you're plugging in 9, plugging in 1, subtracting the answers, done. So on top, I'm going to plug in 9 first. I have 2 times the square root of 9, then cubed. 10 times the square root of 9. What is the square root of 9? 3 cubed? Times 2? 54. Okay, so I have 54 plus. Okay, square root of 9 is 3 times 10 is 30, which means the top came out to 84. Okay, then the bottom, what am I plugging in? Just a 1. 2 times 1, nobody cares. 10 times 1, nobody cares. Gives me 12. Then what do? Minus, so 84 minus 12 is 72. That would be your final answer. You get it?
Yes, we're finished.
Okay, look at your homework. Whew, barely had time. Okay, so look at your homework. I'm going to give you a couple to try. I'm also going to show you how to check them on the calculator. Okay, you don't need a calculator. I'm going to do a couple of them on the calculator up here and then have you try it. Okay, so for number 1, here's how you check it on the calculator. Okay, write on your paper, math 9. Okay, I'm going to show you how to do number 1 right now. Okay, so math, I'm going to go down to deriv. See how it's number 8?
You said 9.
Right, so I'm going to show you. 9 is right below it, and what are the letters? I-N-T. What does that stand for? Integral. Okay, so I'm going to set up an integral, then look. There it is. Okay, 1 to 2. Here, I'm going to put the function I want to integrate, x squared, and then dx. Okay, do number 1. You should get, math enter, 7/3. Okay? So right next to number 1, you should get 7/3. I'm going to give you another one to try. Okay, so number 1, what should your answer be? If you don't get 7/3, you messed it up. Okay, then I'll type in number 2. Okay, what do I push? Math. 9. Okay, then I'm going to go -1 to 3. Then 3x squared minus 2x minus 1 dx. Okay, you can only use this to check your work. If you turn in your paper just with the answers typed in, obviously I will know. Okay, and I will not give you credit. But you can check your work, but you can't just do the whole thing on there. Okay? Do it. You can do it.
Okay, what was your question? Yeah.
So I thought if you was overpowering, that's who why can't you
Okay, here's why. If you have the square root of 4 to the 3, what type of root is this? It's a square root. So this is a 4 to the half of 3.
Who said
Those don't cancel out. Now, if it was a square root of 4 squared, that's why these cancel, is that this is really 4 to the half of 2. Those cross out, it stays the same.
So yeah, that's like I ordered.
If this was a cubic root of 4 to the 3, and a cubic root there, then they'd cross out and just give you a 4. Make sense?
The original one was like 4 raised to 3.
Yeah, the original problem was the square root of 4 to the 3. Now, you actually could do it either way. If you wanted to do 4 to the 3rd, you'd get 64. And then what's the square root of that? 8. So you can do it either way. Or I can square root 4, get 2. 2 cubed is 8.
It doesn't matter if
The order doesn't matter. I just think it's easier to do this order in my head. Because 4 to the 3, if it was not something small like 4, I might have to really think about it. Versus square roots, I feel like everybody knows. And then doing the powers
I do
easier.
like you a lot.
Okay, working so hard? Okay, let's do it. Let's do some work.
Let's not.
I have a question.
What? Yes. I love to help.
Help me on
Not
number
feeling
6.
math today.
6? Okay, so you need to make it x over.
Really? Why?
X to the half, and then 2 x to the half. And then remember that if you have x's on top and on bottom, you subtract their exponents. So if that's 1, and then I take away a half, because they would cancel out, what would be left? Still x to the half. And then on the second one, I'd have to just bring that x to the half up. So it'd be a 2x to the negative.
I did it a lot last semester. I would
No?
leave.
So like here, since I have x's in both, I can subtract. Here, I'm just bringing that up. So I just took this square root x that was on the bottom, it was a half, and I brought it up and turned it to a negative half. And then from there, you do power. So if I add 1 to x to the half, what do I get?
No, it's like,
What?
so like,
You're adding 2 halves.
Oh, you
It's
get
not
3.
bad. It's cute.
And then what do I put in the front? If I divide by 3 halves, I put a 2/3. Yeah? And then here, I'm going to add 2 halves. What do I get?
1/3, 1 second.
1 second. And then if I divide by a half, that's the same as counting by 2. I already had a 2, so now it's a 4. And then from there, you'll plug in 9. And then you'll plug in 1. Now, when you're plugging in 9, you'll have 2/3. And then that would be 9 cubed and square rooted. Cubed and square rooted. So I do 9 cubed and square rooted. And then that would be minus 4 square root 9 because it was a 1/2.
oh, did you already buy your ticket?
So what's the square root of 9?
For where?
The square root 9 is
3 cubed?
Server?
27.
Okay, so I have 2/3 of 27. What's 27 divided by 3?
You said 29.
9 and then times 2. So that's really a 18 minus. What's root 3 or root 9? 4 times 3 is 12. the top is. Now, when you plug in the bottom, you'll end up just plugging in a 1. Okay, let's get to work, get to work!
Miss, my answer is wrong.
Which one, number 1?
Number 2. Yeah, so I just looking at you. I got 14.
Like,
I got 17. Like, basically.
Okay, so it should be x3, x2 minus x. Okay, then you would have plugged in 3 on top. You'd have 27 minus 9 minus 3 gives you 0. Okay, then f of negative 1 is negative 1 cubed is still negative. Negative 1 squared is positive. Minus negative 1. And so then that'd be negative 1 minus 1 crosses out.
Oh, wait.
X cubed is 27. Oh yeah, I was like, what? You're right, thanks. And then here, negative 1 crosses out, but it stays negative if you cube it. Yeah? So that'd be a negative 1, and then this is really a positive 1. So I just get a negative 1 left over, and then what do I do with those? 15 minus negative 1 is 16. Oh, the algebra's bad, people.
And you have to make sure that you are.
Miss, we are in the highest level of math class where it has to also.
Second highest.
Really?
Yes.
I was right.
Stop
I was right. 16.
Because.
Wait, so like, I just add 2 over 2, then I divide.
So it would be a 2/3.
Because I had like
You just
brain
went
cells left and I didn't want to.
Brooke, after school today? Where's mine?
That's the plan, unless she goes to.
Because you're dividing by the same x.
Just skip with
So you're dividing by a fraction, you're multiplying by the reciprocal.
But I'm not going. Miss, I actually forgot myself. I didn't turn on my earbuds. I thought I turned it in.
Okay, well, I'm
Here.
grading it, so if you give it to me, then I don't care. But if you don't, boo. Chris? Oh, yeah, see? Will you pass this back to Alicia?
I probably doesn't want to go to Richmond.
I want it. Can't you change that light color in your settings?
Here, miss.
I had a BlackBerry and I would change it like every day.
Do your homework. You have 5 minutes.
Ew, no.
Failure.
I still gotta be.
Do your homework. If you don't work, yes. Failure.
No, man.
But you are in charge of if you're a failure based on if you do your work.
Miss Jordan, are you gonna be here after school Wednesday?
Yeah,
I'm better than my grade.
I will be.
Okay.
I had for like 5 minutes because she didn't put in my homework. And I didn't take it. I said, I was like,
Jaden, where you going?
I know. I said, what would you like the next day? I almost cried. I was like, 67.
Did you not check me?
Your ass did not get it. Because I got deferred. I'm being reconsidered.
So you can study?
And your ass did not get it.
I'm smarter than
That
you.
infuriates me. I
For
hate
my class.
Smarter than you?
No.
You literally just called me dumb. I'm good at this fall guy.
Yeah, well, I'm glad you find that hilarious. Some of us don't want to get fired over this crap. You're lucky none of your class passed the
Not everything. All these
Wow.
You know how hard it is to be
Anisha had so
She
much
made fun of me. I don't know what it is.
Yeah, but that's your dream.
That's literally, you don't even know. I'm gonna come at you.
Alan, you can shut up.
You want to come back first.
Snapchat.
What's hiding behind the screen?